Hello, everyone. It's Lionel Sender from Pembroke Publishers, and thanks for joining us today for our webinar with Dr. David Costello. Just before we get started, I would like for you to know that Pembroke Publishers' head office is situated upon traditional territories of the Wendat, the Anishinaabeg Nation, the Haudenosaunee Confederacy, the Mississaugas of Scugog, Hiawatha First Nation, Alderville First Nation, and the Métis Nation. And the treaty covering this area of land in Toronto, Ontario, is collectively known as the Williams Treaties of 1923. I would also like to acknowledge and thank the WSÁNEĆ people on whose traditional territory I live, work, and learn. The WSÁNEĆ people have lived and worked on this land since time immemorial. And I wish to recognize the significant contributions of Indigenous peoples across this land. We seek a new relationship with First Nations, Métis, and Inuit peoples, one based in honor and deep respect. And now I'd like to introduce our presenter for this evening or afternoon, depending where you are in this great country. But just before we do, just a reminder that I will be moderating the chat. So if you do have a question along the way, please feel free to put it in there. And I'll turn my camera on and bring that question forward at an appropriate time. And if we have time at the end, we'll also have a little bit of time for Q&A there. But I know there's a lot of territory to cover, and there's a lot going on in the math curriculum across the country. So I suspect David will be taking all the time as he talks to us today about the Insider's Guide to the Math Curriculum. So it's my pleasure to introduce, he's beside me on my screen, but he might be above or below you on depending on how your feed is. But Dr. David Costello, as an author and professional learning facilitator who focuses on mathematics instruction and learning. He's been a classroom teacher and administrator. He's based on the fine island of Prince Edward. And he has supported teachers in many roles, including as a numeracy interventionist, numeracy coach, numeracy leader, and curriculum consultant. He's also taught at the university in areas of curriculum and differentiation, mathematics, and literacy. And he's committed to transforming math instruction and creating more meaningful experiences for teachers and students. And if you've heard David speak before, you'll know that where he comes from is not only that passion as I think I can say a math nerd and get away with it.
You can.
But also, looking at the research and, what is cognitive science saying about learning and how does that help engage students be successful in math. And last time I heard him speak, I was just sort of completely absorbed because he was pulling from, the Make It Stick book and talking about the science of successful learning, but with practical examples connected to math. And I think that's something we can all be looking for, any grade, anytime, any place. So David, it's great for you to take the next hour or so with us, and thank you for that. And I'll pass the virtual mic over to you.
Okay, thank you, Lionel. Everyone, I first want to say thank you for attending our session. I know September 1st, I know some of us are already back at a school. Others are getting ready to head back. So I appreciate you giving up part of your day to attend the session. And tonight we're going to talk about the Insider's Guide to the Math Curriculum. It sounds really like spy-esque, but it'll be good. And my intent with this and with any PD I do is to provide strategies that you can take immediately to the classroom, because I think it's really important that we connect our professional learning to our classroom practices so that we can see how it can impact not only our instruction, but in student achievement. So just a little bit about who I am. I've been a classroom teacher. And like Lionel said, I've been a coach, a interventionist, a consultant, and a provincial math lead. Currently, I am acting principal for my school. It's a K-6 school. We have approximately 370 children. And where I've based this work out of is that I've heard and experienced the stress teachers are under. in terms of instruction, in terms of student learning. And I truly believe the teachers are going above and beyond. Nowhere have I ever heard teachers say, I've got about 30 minutes in the day that I don't know what to do with. And just on a side note, I realize I'm wearing the exact same shirt as in my profile picture, but I promise you that's just a coincidence. Anyway, side note. So Making Math Stick is a book that is about helping us work smarter, not harder. And it's full of learning and instructional strategies that make a difference. And just like what I put in the chat box, I encourage you to use that to post any questions or any comments you might have. Lionel's going to monitor the chat box because I don't want this just to be a presentation of me going on and on. I want this to be a conversation, and I want to ask, and I want you to ask questions so that you can make connections to both what we talk about tonight and some of the slides and materials. So I want you to think about the view of learning. And I've asked this question before, and I've asked it to a wide range of teachers, both from kindergarten to grade 12 and even beyond. I'll say, what does learning mean to you? And more often than not, what learning tends to mean to people is about the acquisition of skills or of knowledge. They'll say it's about learning new things. It's about securing knowledge of things that you might not be familiar with. But when we think about that learning, what we tend to focus on is about learning getting into the heads of students. It's about getting things into the heads. And for that, I think that much of our education system over the past decades has really been about that. It's about getting things into the heads of students. And where I want to suggest is, I think that focuses on short-term performance. That focuses on a teach, test, and then move on. Think about it. What do we do when we tend to go over, when we introduce a new concept? We give students questions on that concept. We see students are doing well, but then we move on. And then we find out down the road that they've not really secured that learning or secured that understanding. So what I want to do is I want to kind of base some of the conversation we're going to have tonight. And I want to broaden our view of learning so that we understand learning is the acquisition of knowledge and skills, but it's also having these readily available from memory to support future meaning-making opportunities. Now think about your class. How many times have you worked on a concept or introduced a concept earlier in the school year, only to have students say later on in the year, I don't remember doing that. Or, we didn't do that. Or a classic example would be a grade 6 student saying, we didn't do fractions last year. When you know for certain that they did do fractions. So what I bolded here is, these are the parts that I'm short on. These are the parts that I think that we're putting all this time and effort into in instruction, but we're not seeing the value added that we're hoping to see from it. And I think we need to kind of think about what we're doing and maybe kind of tweak some of our work so that we're supporting it so that students have this learning readily available from memory to support future meaning-making opportunities. So here is what I want to talk about. Now, I'm going to just kind of in a slide or two go over some of the whole technical terms of this broadening the definition, but after this, I'm going to make it practical. But I just want to kind of categorize the 3 stages of learning. So encoding means you're getting knowledge into your head. So if I'm reading something for the first time, and let's say it's about the double-double multiplicative strategy. When I see that for the first time and I'm understanding, oh, so when I multiply a number by 4, it's just really doubling that number twice. That's me getting it into my head. That's the encoding part. The consolidation part comes next. Is when we attach meaning to that. So that might be when we connect it to some of our previous learning or some of our previous understanding. It might be, okay, so the double-double strategy is really doing the double strategy 2 times. So I'm connecting it to that double strategy, and I am assigning it meaning, which means it's going to stick in my memory. Or it might be, okay, how is the double strategy different than the clock strategy? So I'm comparing and contrasting, and all the time I'm adding additional layer of memory to that double strategy. And here is the last one, the retrieval. This is an important part of learning that I think we overlook. It means, how do we get knowledge out of our heads? So it's to make meaning, but how do we support them in getting this out? They back and they bring something that we previously learned into mind. Because I'm just wondering sometimes, do we do a lot of one and done? We see it, students demonstrate understanding what we think is their understanding, but it's really just short-term performance, and we move on. But now you're going to be impressed with this next slide, because what I did is, look at this. Everyone see this slide? Look at what I did for the next one. I kept the exact same slide, but I just added arrows to it. It's pretty crafty, isn't it? This is what I think we need to do more with the consolidation, the assigning meaning, but also supporting students in retrieving this learning from our memory. Because the more we retrieve something, the stronger the memory becomes, and and I want to say the easier it becomes to remember and apply that. So then that's the whole point of, oh, look at the video. This riveting book, Making Math a Stick. I'm hearing great things about the book, and I'm hearing great things about the author. It's a little joke because it's me. So just like a cognitive science jargon. So this is a whole evidence-based, research-based bit to it. Every time a memory is retrieved, or every time you think back to previous learning, the individual must think about it once again. They must reconstruct it in terms of not only what they thought back then, but also in terms of our current experience, and then they must consolidate it again. So what happens is we're re-engaging with this memory. We're coming at it with a new experience since we've seen it last, and we're strengthening it. So the memory becomes strengthened. And then from that, the really cool thing is, based on brain research and cognitive science, the brain organizes our memories more efficiently every time they're retrieved. So every time we recall previous learning, the pathways to these memories are strengthened, and the cues to these memories are increased. So our brain naturally makes these memories more accessible. So the more we retrieve something, not only does the memory get stronger and we add detail to it, but it becomes easier to recall. So therefore, it can be argued that retrieval is a more powerful learning activity than encoding. Think about that. Retrieval is a more powerful learning activity than encoding. So the more times we retrieve something, the stronger that previous learning becomes. Now, the really cool thing about that is, well, that's great to know because that'll help support learning. But the way our education system is set up, do we really do that? Do we really provide students with retrieval? And yes, Jody, thank you. I'm trying to make this entertaining. It's like plus 98 degrees, and it's the 1st of September. And I know that we have much computer fatigue, so we're trying to make this, what the young people say, engaging and hip. So just coming back to that, think about that. The more retrieval we have, the stronger the memory becomes, and the easier it becomes to retrieve that memory. So why aren't we doing more of it? And this is where it's about working smarter and not harder. And I want to kind of preface this right now. Anything I show you, it's not going to add work to your instruction or to your planning. What it's doing is it is taking things that you already do in the classroom and it's using them in a more effective way. So you're not reinventing the wheel and you're not having to craft all these new tasks or questions. It's about using what you have differently. Hence, the working smarter, not harder. But because I really don't think that we can go above and beyond what we're already doing. And just to kind of show you how we're going to talk about this, the how do you retrieve, there's 3 ways. One, instead of squeezing them all together, like instead of if I'm talking about converting mixed numbers to improper fractions, instead of only doing that for a 2-week block, why not give the questions, why not come back to that later in the year by providing students with the opportunities to engage with a prompt or a question so that they have to go back to their memory and retrieve that. The mixed part, so many times when we give questions, when we have students practice, because practice is good so long as practice is purposeful. If it's not purposeful practice, then it's not really meaningful. So when we tend to give practice, we tend to give practice all on the same concept. So students don't have to think about which concept do I have to apply. They just have to think, okay, all these questions are on multiplication, so I'm just going to focus on multiplication. So they're just only looking at how to apply the strategy. So we need to mix our review and our practice up so it has different questions and different concepts in it. And feedback. Students have to know if their responses are correct or not. We don't want students thinking they're correct when they're not, because practice does not make perfect. Practice makes permanent. So if we're doing something and if we're not doing it the accurate way, the more practice we do with that, the more we're going to reinforce that inaccurate way. So don't forget that practice doesn't mean perfect. Practice means permanent. So now look at this slide. This is my intro to the curriculum. Oh, I thought I just will go with the word. So we are going to look at 6 major topics or strands in the curriculum here. And I know that each province and jurisdiction has their own. But what I want you to think about is there's great commonality between them. So let's look at the first one. We are hearing a lot about social emotional learning skills. We're hearing a lot about it, both in terms of curriculum and in terms of learning. So what is social emotional learning skills really focuses on? It focuses on students' development and application of the skills that support student learning of math concepts and skills. So it helps students learn the math concept. It fosters their overall well-being and ability to learn, and it helps them to build resilience and thrive as math learners. So it's about supporting them and not giving up when they hit that first stumbling block. And as students develop social emotional learning skills, they demonstrate a greater ability to understand and apply the processes to supporting learning in math. So what I want to think about is people's like, sweet mother of pearl. How do I do that? How do I apply that to retrieval and to learning? Well, let me show you how. So let's think about awareness strategies. And all these strategies are from my book, Making Math Stick. And many of them are contained within the Insider's Guide to the Math Curriculum, which posted on the Pembroke website. So what an awareness strategy is it helps students learn, and it helps students understand how they learn. It helps them remember what they have learned, and it helps them apply what they have learned to new situations. So that's pretty significant. It helps them learn, helps them understand how they learn, helps them remember what they've learned, and helps them apply what they've learned to new situations. And you would apply awareness strategies when engaging with math concepts. And what this does is it strengthens the student's ability to make meaning, thereby layering the memory and increasing opportunity for retrieval. Yes, Gail, I see that, and I think it's because even though I have supposed high-speed internet, I think it's really internet with the speed of a dial-up from like 1991. hopefully we can get everything worked out. So we can use awareness strategies to support students in social emotional learning skills. And here are 5 examples of awareness strategies: prioritizing aspects of a problem, summarizing a problem solving experience, reflecting on a problem solving experience, use a learning journal to record key takeaways, and record next steps. And these are strategies that really would take 5 to 10 minutes in a class to have students do this. Students can write about these, students can share them with partners, students can share them with the teacher. And here would be an example of a summarizing problem solving from an elementary student. And it's summarizing favorite strategies. um, a student looked through multiple samples of their work and listed the strategies they typically apply to solve the problem. So they're going back to like their portfolio or their learning log. And compiling the summary made them more aware of the strategies they gravitated to, and it strengthened the recall of these strategies. So the more that they were kind of going back and looking through their work, they were really examining their previous learning. And the more they engage with that, not only did they strengthen their understanding of the math concept, but they strengthened their understanding of the problem solving strategy. So, how are we so far? I got a lot to share, and I want you to leave with a lot of things to take back to the classroom. So, I'm hoping all this is making sense, because really I could talk about this all day. I was actually thinking about it on my way home from our work. So we're good. If you've got any questions, put them in, or feel free to stop me. So the next strand that's in all of the curriculum, number. And when I was going to school, what people thought about number was arithmetic. If you could add, subtract, multiply, and divide. But number is so much more than that. It's about whole numbers. It's about decimals. It's about fractions. It's about percents. It's about integers. It's about rational numbers. And really, what we want is we want students to be able to understand numbers, to be able to understand how numbers relate and how we can break them up and put them back together. And we want them to be able to understand not only how to add, subtract, multiply, and divide, but we want them to understand the actual operation. Because I think sometimes what we focus on is we focus on the computation, which is just really how do I add, subtract, multiply, and divide. But we need students to understand the operations and to know how the operations relate to one another and when to use add, subtract, multiply, and divide. And it's about the math facts too. We want students to have automaticity with that, because what research tells us is if students are using a lot of cognitive energy on how to solve a fact, that is taking away from energy to problem solve. So why we want students to have automaticity with the facts is that they can dedicate more of their working memory and more of their cognitive energy into the greater problem instead of just one of the aspects of the problem. And I have a question from Sarah. How often do you suggest students write summaries of their learning? So in my own class, I would say, do you know what? I'm not going to do this every day, and I'm going to be strategic. So I might say, do you know what? Can you write me a summary of da 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 da? And I might do it every few weeks on a different concept or on a strategy. It might be on a concept like tell me what you remember about continuous data, or tell me what you remember about about surface area. But I'm not doing that all the time, because what we want retrieval practice to be to support the retrieval stage of learning is we want them spread out over time. And a summary could even take the form of an exit ticket in your class. You know what, boys and students? We have not talked about this in a long time. Tell me what you know about perimeter. Tell me what you know about measuring angles, something like that.
I know, David, just to jump in there, and this was more sort of for, I guess, teenagers, but I used to do it was like a journal, but they would go back through the week and they would have to pick out a problem that was either hard or they were proud of or something. And I was stunned at just the things that you miss because, they're inside struggling with this, and then to actually having them write it out and summarize and talk about how they struggled or how they solved it or how proud they were of themselves. It was really a powerful moment. So yeah, it's just, there's so many different ways I guess you can take that.
Well, it is too. Lionel's correct there because, and when I was hearing Lionel say that, and it goes along with this too, it is a powerful instructional strategy, but it's an even more powerful learning strategy, in that students go through that, and it's not. When I say writing in math, I'm not talking about, okay, after you solve the problem, write a few sentences on this. That's not helping them engage. Using writing purposefully to go back and applying the previous learning to it, that's where we get the real bang for their buck.
Yeah. Excellent. Good.
Perfect.
Okay, I'll turn off now and let you get back to it.
Come back at any time. And I don't know if people see, but we actually match shirts. So it's pretty impressive how far we go to bring a team effort.
It's another strategy. Yeah.
It is. So that's what we have about number. And these math facts are gradual over years. Mastery comes with practice, and practice helps build fluency and depth. So here is a strategy, and it's a game changer. It's been a game changer for schools that I've been in and for schools that I've shared this with. And in fact, I was working with two principals from a district I worked with last week, and they were commenting on daily cumulative review and how it's been that kind of that moving forward moment for not only them but for their school. So rethinking review, what it is what is lacking in the traditional approach to review is spacing and mixing. We need to offer students questions that address different concepts, so that students have to read the question, think about what is this asking, then they have to think about what strategy am I going to use, and then they have to apply the strategy. And the cool thing with daily cumulative review and rethinking review, students have multiple opportunities to engage with a concept. They have multiple opportunities. So it's not just the one and done. So the more students address a concept and come back to it, the greater that memory is and the greater the retrieval is. And it gives students opportunities to address misconceptions. So let's think about what is daily cumulative review. What it is it engages students in thinking mathematically. It's 3 to 5 questions that target multiple concepts, strategies, and or skills. If you're in like K to 2, I would say 3 strategies. If you're, maybe even grade 2 and above, I would go 4 questions. And it builds fluencies. What it's not a prelude to the day's lesson. So if I'm having a lesson on surface area, it's not about surface area. And it's not 3 to 5 questions that address the same concept. And they're not heavy duty, time consuming exercises. What it is, this is the great thing. You give like 3 to 5 questions, or let's say 3 to 4 questions. You give your students 5 minutes to work on them, and then you use 3 to 5 minutes to share what the solutions are. And then students have to look at their work and have to recognize whether they had the solution or not. So that gives them the feedback, the metacognition. And I'm looking at Sarah's comments. Yes, number talks support fluency greatly too. Daily discussions about various operational strategies and about coming back to some of those operations throughout the year. So we're just not focusing on multiplication in this block, but they have multiple opportunities with it. And talking about two teachers were using this starting 2 years ago. Yeah, 4 questions. I've done a bit of work in your board and with a few schools, and they seem to be really promoting this. And here would be an example of daily cumulative review. So when I was working with the teachers, this was from grade 3, and the grade 3 teacher said, you know what? When we sat down as a group and when they looked through their school data and trends, they said there's really 4 areas that we really see students need support with. And these are big concepts. One was place value, one was perimeter, one was subtraction, and one was equations. So what they did was they crafted 4 questions, and they would start every day with 4 questions, 1 question on each concept. So you can see like Monday's questions and Tuesday's questions, we're addressing the same level of a difficulty, because it's not about engaging with a time-consuming exercise. It's about going back to concepts and being able to retrieve them, because the more we go back to them, the stronger your understanding of the concept is, and the easier it is to retrieve that concept. Now, just to kind of, as a side note, my wife taught a grade 5-6 combined class, and what she would do, she did daily cumulative review Monday, Wednesday, and Friday. Last year, I taught a grade 4-5 class. I did it every day. Someday I would write 4 problems on the board, and my students would write them in a scribbler, and then I would show the solutions on the board, and they would check. Other days, I would write them on the board, and the students would write them on the whiteboard, and they would just hold them up. So there's different ways you can do to make this work. And then, so you can see that in each day, we address the 4 concepts, and it's the same 4 concepts. So what I did in my grade 3-4 class and in my grade 6 class that I had last year, I would focus on 4 concepts for like, just say group A concepts, 4 different concepts in September, October. Then I would find a different 4 concepts for November, December. And then in January and February, I would go back to the first 4 concepts. So I am cycling through 4 concepts every 2-month block. And it really helped students with those concepts so that they could apply them to future problem-solving situations. Okay. So algebra, also called algebraic thinking, also called pattern and relations. And this strand or this approach or this concept is all about working, and it progresses from working with simple patterns, kind of like A, B, to basic algebraic concepts, solving equations with unknowns. And we're starting to see developments within some jurisdictions that they are having coding as part of the algebra strand, and they're starting that off early, and I might be talking about moving in different directions, and they're going all the way to more advanced coding. And we're also seeing mathematical modeling. Plug working on support for that should be released in the spring by the great publishers at Pembroke. And how I view mathematical modeling, it's within the problem-solving umbrella, but we're using ill-defined problems, something that I think we need to get more experience with in a school. And the great thing is that both coding and mathematical modeling highlight the importance of applying algebraic thinking to solve real-life situations. So it's about applying our skills, and it ties in really well with STEM. It's about applying these concepts and skills to real-life situations. And I'm looking, Sarah, do you ask students to show all their work during the cumulative review? Yeah, students on their work, they will show their work. And when I'm solving the 4 questions, I will show the process solving it. And then they will have to look not only at their response, but at their work to see if it makes sense. And we do that quickly because the questions aren't time consuming. So when we're thinking about algebra and pattern and relations, we can do this with a group of strategies called learning by picturing. And what visualization is, it's a learning strategy that involves representing the concepts as mental images. And let me just give you an example of this quickly. I want you to think about the term I'm going to say, and I want you to think about it as a picture, or think what's the first thing that comes to mind, and I want you to type it into the chat box. What do you think of when I say quarter? That's a car going by that just honked the horn. I think that they were engaged in this too. What's the first image that goes through your mind when I say a quarter? I have people putting money, 4 quarters in a dollar, money, a coin, 25 cents, 25 cents. Did anyone, a piece of something, 25, 15 minutes on a clock, 4 parts, 1/4, money, time, part of a pie. Oh, what kind of pie? Julie Bennett, fraction of a pie. So think about this one term and think about all of the mental images that came to your mind. Visualization is a part of how we learn. Mental imaging is a part of how we make sense of things. So when students apply visualization to learning, they work with different areas of the brain, thereby strengthening both the memory and the pathways. And there's research on this, and I know you didn't come in here for a research presentation, but when we're thinking about it in terms of words and visuals, they use 2 different parts of the brain. So what that means is that we are adding layers to our memory, and that not only helps strengthen the memory, but it helps give us additional pathways to the memory. And what are examples of learning by picturing? Visualize a problem to see it, free sketch, to explore, create concepts maps to find connections and relationships, and create graphic organizers to organize thinking. And we're going to share an example of visualize, but I want to kind of stop here just to have a little disclaimer note. Graphic organizers are a great learning tool when we understand completing the graphic organizer in and of itself isn't the whole goal of it. The goal is, how do I use this graphic organizer to make sense and to strengthen my thinking? So it's not about completing a graphic organizer, but it's how are you going to use that graphic organizer to strengthen your thinking? So here is a visualized problem. The equation was 3x plus 2 equals 14. And if you're doing these problems, I said it like that because I want to kind of preface something. If we say 3x plus 2 equals 14, we're not really highlighting the importance of the equality concept. So another way we can do that is 3x plus 2 is the same as 14. So look at how the student visualized this. What the student did first was think, okay, 14 here. Then they put the 2 over here, and they realized there was 3 x's. So when the student took those 2 out of the bucket, they realized, okay, so that would have to be 12 in that bucket. And if 3x equals 12, how many would x equal? So that's how they do that. And just look at the visualizing. This can tell you a lot more than if the student just put 3x equals 12, x equals 4. This is adding a layer to their thinking. So it helps you as the teacher but it also does a great job in supporting the student as a learner if they're looking through this, because they're strengthening their concept and they're strengthening pathways to it. So that's visualization. Now we have data. I love stats and probability. I feel so bad that probability usually gets left until like June 15th and June 25th. It's a shame. And there's a movement out there really stating that this is one of the more important concepts because this really has a lot of real life significance to it. And the focus of this strand is on skills of collecting, organizing, reading, representing, and interpreting data. And students are also expected to understand the meaning of probability concepts and how to apply these. Riveting, I know. And we can do learning by writing to support data or stats and probability. And here it is. There's two types of writing that we tend to see in education. One is writing to demonstrate knowledge, and we do a lot of that. And what I mean by writing to demonstrate knowledge, it is when we ask students to prove that they know something. So kind of like a test. But then there's writing to learn. And what writing to learn is, it's an informal exploratory approach that consists of short, informal writing tasks that provide students support as they think through math concepts. So writing to learn is a learning strategy, and it makes student thinking visible. And here are some examples of writing to learn. Paraphrase a problem to help them understand it. So if you're giving students a problem, before they even think about what strategy to apply, ask them to read or write it in their own words or to tell you what it is. Because if they don't understand the problem, shouldn't we be supporting them with that instead of moving forward to crafting a plan? Approach a problem doing a free write. Tell me everything you know about discrete data. Now, some people might think a free write, that is just a time killer. Well, really, it's not a time killer. And let me tell you why. When students have to do a free write on a concept that they previously explored, what they're doing is they are searching their previous learning for the concept. And we know every time they go back to that concept that they're adding layers of meaning to that concept, and they're strengthening pathways to that. And it helps them organize their thinking. And taking that up one step, it's called do a free write of 30 words or less. That is where I might say, okay, in 30 words or less, tell me about surface area. In 30 words or less, tell me about a decreasing pattern. In 30 words or less, tell me about a reflex angle. Now, it seems really straightforward, but what students have to do is they have to kind of go back and search their previous learning, but then they have to organize their thinking in a way to highlight the most crucial points in 30 words or less. And a plus-minus chart to record what they know and what they don't yet know. Okay, and I'm just looking in here, just at the chat box. Data was taken out of curriculum. This is a subject that I taught that I used to attend. Tina, what would you suggest for students in grade 2? I'm dealing with students who have a challenge with a fat cat sat on a mat with a rat. It is flat. A flat cat sat on a mat. They have to synthesize what they know when there is a word limit. Yeah, and they have to weed it out. So, yeah, I'm not quite sure. If you could kind of clarify what you're thinking, and I apologize, but I will address it.
David?
What? Yes.
Yeah, I think Tia's was saying is you're in she's got grade 2 students with not necessarily a large vocabulary, and comprehension issues. So if we're doing a free write and it's 30 words or less, even 30 words might be too much. I think that's where she's coming from.
Okay, perfect. Okay, so that makes perfect sense. So then what we can do is if students are really having a difficult time with the whole writing piece, they can scribe it to you, and then somebody can record it, and they can do that through like Google speech to text whatnot. But when you think about 30 words or less, 30 is an arbitrary number. You can do 20 words or less. You could do it as a shared write, as a group activity. Yeah, and like Jody's comments, you can speak at 30 words or less too. And the great thing is you can put it down and then you can revise it either individually or as a class to work through it. So there's different ways to do this. I always wonder about the amount of writing we ask as students to do for math. Completely agree. These are things that I wouldn't do every day, but these are things that I would have in my toolbox to pull out over time. And the great thing is when we say learning by writing, any of these we could substitute by learning by talking, and we could be doing these aloud. And here would be an example of a plus minus chart. So the students were given the prompt, a local business shared its profit for a 6-year period. There's the year on the left, there's their profit on the right. And then students were asked to create a graph to help support each of the following. A, that the company for the past 6 years has experienced a small profit increase. So create a graph that'll support that, and create a graph that'll support the company has experienced a large profit increase. So what we're wanting students to know is based on our scale and based on our broken graph, on depending on where we start our y-axis, we can manipulate this graph into have it appear to show a certain thing. And what the student did with the plus minus chart is on the plus part, I know the 5 necessary parts of a graph. Here they are. But on the minus part, I don't know if this is discrete or continuous data. I don't know how to start not at a 0. And I don't know how to make 2 different graphs for the same information. And what we've done with these minus parts is those become learning goals. And we can do that either individually or in groups. So it really works well in that we highlight what they know, but they can come back to the minus chart, minus column, as a way to kind of show them, okay, here are some of our next steps we could use. And spatial sense, the strand that combines areas of geometry and measurement to emphasize relationship between the 2 areas and to highlight the role of spatial reasoning. And it provides students with a language and tools to analyze, compare, describe, and navigate the world around them. So what I use for this is building a network of memory. And it's about adding more details to the memory of a concept and gaining the ability to situate it within a greater context. And here are some examples. Create and answer how and why questions. So ask students to create some questions, how and why, about that. And you can do this as a group activity. Explain their thinking. Use dual coding. And what dual coding is show me, taking a brain fart. Show me what an increasing pattern is using both pictures and words. Compare and contrast concepts, generate concrete examples of an abstract idea, and make connections. So here's an example of compare and contrast. The students had to create a T-chart, and they had to compare contrast for area and perimeter. And what research tells us when we compare and contrast, not only do we have to hone in on the specific attributes of a concept, and we have to dig into the finer details, but then we take that one layer deeper into comparing it to the finer details of other concepts. So not only do we learn more about each of the concepts, but we situate the 2 concepts in relation to one another. So that adds to the layers of understanding. And one more is financial literacy. So financial literacy is more than knowing that the coin with the blue nose is worth 10 cents. It's about developing confidence and capacity to successfully apply the necessary knowledge, concepts, and skills in a range of relevant real-life contexts. And while financial literacy may not be a strand in all jurisdictions, it's gaining significance in math across Canada and the United States. Once again, it's going to the real-life connection piece. And what we can do for that, and an example of financial literacy might be, is it better to buy the product in a single pack or in a group pack? And how do we know this? And strategies we can use for this is adjusting common fees. So it's applying this to Croce's review of a space perspective, or box it with other concepts. The exact being between figure it out and here it is. And figure it out means that you're giving the students a problem and you want them to on their own. Here it is means you would. And here would be an example of a think, pair, share. The prompt would be, how do you decide if you would prefer to buy a package deal or a single price item? And you're giving this to the students without any numbers involved, because you want them to think through this process and to think through the strategy. So the students would think students were first asked to consider how they would approach it, record their thinking with speech to text, or to record their thinking orally with the teacher. Then students would be assigned a partner with whom they share their thinking, and they would talk through each of their thinking as a way to rationalize their understanding, to explain their thinking, and to find commonalities and differences between them. And then students would partners would share their. Students have to decide to. And just Charlie says a. Fine, no. Did you vote? So the think, pair, share we use to math. I like these two things. And what we mean by a spiraled curriculum, traditionally, oh, sorry about the sound, everyone. Here, sorry. Okay. So a spiraled curriculum is really a different way to approach a year plan. Instead of addressing concepts only one time throughout the year in traditional year plans, what we've done is we have spiraled the outcomes throughout the year under big ideas, so that students generally engage with a big idea 3 times during a year. And what that means, the first time that you engage with the concept, it's more introductory. The second time you dig a little bit deeper and it allows you to address any misconceptions. And the third time you really go deeply into it in a problem-solving context. And by providing multiple opportunities, it allows you to address any misconceptions. And I want to say, some people think, I barely have time to address a concept one time a year, let alone 3. Spiral curriculum is something that doesn't focus on coverage. It focuses on learning, and you will see how it saves time. And it makes such a significant difference in that we're not worried about checking off concepts as we're opposed to, as we are to have students learning concepts. And another one would be homework. Some jurisdictions use it and some don't. But if we are going to use it, why not approach it from a retrieval practice solution? Whereas you could give 2 problems that are on a new skill, and these problems are just enough for students to approach the concept while avoiding the possibility of reinforcing a misconception. So it comes back to, we don't want practice to make permanent if there's misconceptions. Then they have 4 problems requiring recall of previous concepts. So they're retrieving those previous learning, thereby strengthening their understanding and their ability to retrieve. And then there's 2 problems that are a bit more complex that require problem-solving scenario. And this could be for a week perspective. And it just addresses the concepts you're working on now, concepts from the past, and a problem-solving scenario as a way to kind of strengthen thinking and really helping make math stick. And if you go to my website, I hear it's a riveting website. I have instructional videos. I'm doing problems of the week, problem solving, and I post blogs on there in Classroom Connections. And there's my website. There's Pembroke Publishers. And everything I've taken tonight is just a snippet of stuff in making math stick. And if you need any support with these concepts, let me know. I'm here to help because I think it's important that we help one another. But the one thing that I will say, if you're interested, let me know. And if you have questions about concepts or about spiraled curriculum, because that's new for a lot of jurisdictions, let me know. But it can be a game changer. And there's my contact info. And I'm looking at the time, and I'm going to stop talking.
Perfect timing. Well done. Yeah. I just was watching the chat going. I think you did a good job of capturing all the questions as they came through, David. But we probably didn't get a chance to sort of see the Twitter and the folks. Thank you for the folks that were throwing out ideas. But clearly, practice makes permanent caught for people today, and I think that was a very powerful statement that sort of stuck with many. So I know what you mentioned it there very briefly, but as the author, probably not, you don't want to self-promote too much, but David did pull from his book today. And I was following through as you were talking, David, and going, there we are. There it is there. And
oh, it's yeah, a great book
what was the word you're using earlier? Riveting. So
riveting.
Just so folks know, Pembroke Publishers is happy to just have a little enticer there to maybe have you investigate David's book a little bit deeper. If you use the code IG21 when you go to Pembroke Publishers and see his book, you can get $5 off your purchase as well. So we encourage you to take advantage of that. Also, David kind of mentioned it briefly there, but he is this year coming together for a six-part, right, David?
Yeah, six parts.
Six-part series of getting together and going much deeper into these different sections within his book. There is a fee for that, but we encourage you to watch your email. There'll be some more information coming out on that fairly soon, but we're really excited about it. You can't give justice to all the work that David's done, not only in his book, but also on the online support. And a six-part series seems like we can do something with that and can really build on some themes. So please watch for that, and we would love to see you back for that as well. So David, maybe I'll just let you finish this off, and we'll close with your final thoughts.
Yeah, everyone, thank you so much. And what Lionel said, so the 6-part webinar is meant to go deeper into each of these strands or concepts, and why we've spaced it out in a way so that it's a support as you are working through these. So it's kind of like at the moment PD at your fingertips. And I know that I've messed that phrase up completely, so I'm just going to move on with that. But everyone, put me to work for you, because I think that it's important that we help one another. And there's my contact info. And I look forward to seeing you again. And I want to thank Lionel for all of his support for this. And I want to thank Pembroke for this opportunity.
Great. Thanks, David. And thanks, everyone. And we look forward to seeing you next time. Have a good evening.